Hello, so today I'm going to be showing a concentration solution equation. And the question is, how many milliliters of a 0.291 mole solution of carbonic acid would be needed to have a total of 4 grams of carbonic acid? Now, before we begin to write out the conversion factor and the conversion plan, we should first write out the formula for carbonic acid right here. So there's a rule with naming acids and bases, especially if they are common ions. So for example, if the common ion carbonate, which is the formula CO3 with a -2 charge, if it ends with an ATE, it has to have an ending of ic and then acid at the end. So that's why it's carbonic acid. Out of that, it's carbonate, because any common ion that has an ending of ate has to have an ic as a replacement of the ate. So it'll be, instead of carbonate, it'll be carbonic, and then you have to add acid. So we can't forget the -2 charge of carbonate. So in order to make that into carbonic acid, we need to make the -2 charge as an H2CO3. So basically just simply put it in front, make it positive, and add the H. So again, it would be H2 plus the common ion, which is carbonate, which is CO3. And a simple little riddle to remember this rule: if you ate an acid, it might taste icy, but obviously the ick. So anything with an ending of ate would have an ick plus acid at the end. So it's just something that can help you remember this rule. So now that we know that carbonic acid is H2CO3, we can now write down a conversion plan of the units that we need in order to get milliliters of carbonic acid. Okay, so I have written down the conversion plan, and it goes from grams to moles, then moles to liters, and then liters to milliliters. And it's set up this way because first we have 4 grams of carbonic acid, and then we have 0.291 moles solution, and then from moles to liters, we have liters, and then we need to convert liters to milliliters because that's what we're trying to find at the end. So I have made the conversions, but we're first going to focus on each step-by-step conversion units. So we're going to start with grams to moles. So our beginning number is 4 grams of carbonic acid. So that's how I started here. And now, in order to get moles, which is what we're looking for, we need to cancel out grams. So grams of carbonic acid would be at the denominator, so these would cancel. And then now we have moles of carbonic acid. So now we're looking for moles to liters. So we have moles of carbonic acid, and we need to obviously cancel this out. So moles of carbonic acid will be at the denominator, but in this case, the mole solution. And since we're looking for liters, liters will be in the top. So moles of carbonic acid will cancel like so. And now you have liters of solution. And last but not least, you have to look for liters to milliliters. So you have liters of solution at the top, and you need to cancel it out in order to get milliliters. So liters will obviously be at the denominator, so these would cancel. And now you have the final unit that you're looking for, which is milliliters, as stated in the question right here. So now that we have the unit conversion planned out, we are going to first plug in its numbers. So for grams to mole, we would figure out the grams of carbonic acid by adding up its atomic mass. So since there's 2 hydrogens you would multiply 2 times hydrogen's mass, which is 1.01, plus carbon's mass, which is 12.01, and there's only one of them, which is why you only put 1, plus 3 oxygen, so 3 times oxygen's mass, which is 16, and the answer for that would be 62.03 grams. So, for every 1 mole, there's 62.03 grams of carbonic acid, and that's how you find the grams to mole ratio. So to find out the units for liters to moles, you would refer back to the original equation, how many milliliters of a 0.291 mole solution of carbonic acid. So mole solution. So based from the equation, we can write 0.291 in 1 liter. And that's how we know the number of moles, because we can derive it from the equation. So in order to convert from liters to milliliters, we would refer back to the unit prefixes chart. So milli is 10 to the negative 3, but always remember that the negative 3 would be positive and that the bigger unit would have a 1. So in this case, liters is obviously bigger than milliliters, so liters would have a 1, and milliliters would have a 10 to the positive 3 number. So after you plug the numbers into your calculator, you should get an answer like this. But I just wrote it in shorthand version. So I wrote it as 2.215 times 10 to the second milliliters. But don't forget your significant figures, and our lowest number of significant figures is 3. So I would have to write this number as 2.2. So we need 3 significant figures, and the number next to the last digit that we need is 5. And anything 5 or above, we have to round it up. So we have to round up the 1 to a 2. So it would be 2.22 times 10 to the second milliliters. And that is how you solve an equation that involves concentrations of solutions.